Hello, in this video, we will design the graph class to model the graphs. We're going to define this interface graph for all the common operations in the graph. Get size returns the number of vertices in the graph. Get vertices return all the vertices in a list. And get vertex using this index returns the vertex at the specified index. Get index for the vertex. Get neighbors for the vertex at the specified index. Get degree for the vertex at the given index. And print all the edges and clear to clear the graph. So it's now empty graph to add a vertex, add an edge. Add edge using this edge object, and remove vertex, remove edge, and this is the a depth first search and a breadth first search. We'll talk about this in the future video. So now let's look at this is the concrete unweighted graph class. So you're going to create this all the graph objects and using this constructors. Now, this is the concrete implementation. So how do we store the vertices? We use a list of vertices. And how do we store all these edges? And we use this neighbors, and this is a list of edges. All right, so let's look at the implementation for the graph interface. So this is the interface for the graph. And this is interface graph. And get size, and get vertices, get vertex, and get the vertex at the specified index, and get the index for the specified vertex, and get all the neighbors, and all these neighbors are this is a list of integer. So all of this, and look everything here, and so this is all we need to understand it and use this. And this is the implementation for unweighted graph. So this is the one. So this is constructors constructing an empty graph and construct a graph using this an array of vertices and using the edge is two-dimensional array is edge array. So, and there are other constructors. Now, you can now write a test program, assume that we already have this concrete class implemented. So I'm gonna write a test program and use some of the methods here. So first, I'm gonna go this test graph. So let's write some code here. I'm going to start with this. Let's just go with this. I'm gonna have a graph of, let's put the integers now as the vertex. And now we're gonna have a new weighted graph. All right, I'm gonna add this into the graph. So this right now, it's empty. If you print this graph one dot get, so let's call this as graph dot get size. This is going to be 0. So this is graph 1. Now we're going to have a graph. This is the graph now. Graph dot. Let's add a vertex is 1. Let's add vertex is 2. So now let's have an edge at edge between this two, 1, 2. And now we're gonna have this as undirected. So we need to add both at edge 2, 1. All right, so now you can print everything. So here is the print edges. So we're also going to have system.out graph dot print ages. All right, let's give it a try. I'm going to run this program now and see this is the output here. I misspelled this vertex, and so this is right here. So let's run this program now and print ages. And so here is, all right, so this print ages is the void. So we have to use this print ages. It's a void, okay? All right, so this is the output, and we're going to have this is the illegal argument exception is for this is at 6. So when we add this age, so add age 1 to 2 and 2 to 1, and so we have, okay, so that's the issue here, the index. So the index actually for this 1, when you add it, this is actually 0, this is a 1. So the vertex, we need to get the index. So using this U and a V, so you have to use this graph dot get index for this right here. This is the object. This is 1 here. You have to get this, its index. This is actually 0, so you can write it, this is return 0. So graph dot get index 2. And the same thing here, you have to say this is graph dot index 1. And this one is graph dot index 1. And this is a 2 here. All right, so that is the reason here you have the illegal argument exception. Now let's give it a try now. Everything works fine now. You have this number of vertices is 2. So those are the vertex. So here is from 1, you have age 1, 2, and so that index is 0, and 2 is index is 1. So whenever you add a vertex, and that vertex, it's the index is automatically assigned starting from 0. So let's make a small change right here. Let's do this. I'm going to copy and paste everything. And so let's make a change right here using string for graph 1. And this is here is Savannah. And this is Atlanta. All right, so everything else, no change. So now this is 1, this is 1, this is 1, this is 1. You add the ages. So now this is graph 1, so I'm going to have the size for graph 1, so this is graph 1. All right, so let's print it out, and you can see that we are getting, so here is string. You're going to add to vertex Savannah. I'm going to change this is 1, this is a 1, this is a 1, this is a 1. All right, so now run this program and get index. All right, so I have to change this to index for Savannah, index for Savannah, and this is index for Atlanta. All right, so let's give it a try now. All right, so look at this. Its number of vertices for the second graph is 2, and the vertices here, Savannah at index 0, and there's age from Savannah to Atlanta, and Atlanta index is 1, there's age from Atlanta to Savannah. That's all for this video. See you on the next video.